which you can leave. Let's understand. So firstly, we are given a string array called as words. As you can see, we have a string array having an array of, it's an array of strings. We have to return an array of all the characters that show up in all the strings within the words, including the duplicates. That's a very, very, very big thing which I missed when I read this problem initially. And thus, I took more time in this easy problem. I'll tell you what I thought and then how I reached to the actual answer. Now, you may return the answer in any order. Cool. Okay. Which means this answer, which means the string which are repeating, or you can say characters which are repeating, I can return it in any order. So in the very beginning, I asked that I have to tell some characters which are in all of these strings, right? So the actual, like whatsoever I have initially, let's say I have 4 characters. So for sure, it's highly likely either all of them will remain or they will decrease, because I want to know that, okay, if I have B, E, L, L, A, I have B, L, L, A, so it should be in all of these locations. Okay, I will check, okay, is B here? Yeah, B is here. Okay, B is here. Is E here? Yeah, E is here. Is L here? Yeah, L is here. Is L here? Yeah, L is here. Is A here? No, A is not here. So now in the next step, I took the previous step, all the characters, and then I got B, E, L, L is here. Okay. As I will go on, I will again check, okay, is B here? No, B is not here. Is E here? Yeah, E is here. Is L here? Yeah, L is here. Is L here? Yeah, L is here. So ideally, I got in the last, I took the previous characters and I got these characters in the last. Right. Okay. Now, what do you think? What can be the missing thing? Like in this approach which I told you, what can the missing thing? The missing thing is we realized that the characters are decreasing, like their frequency is decreasing ideally. But when I was checking, is L here? So I was checking, is L here? Yes, is L here? I was checking, is L again here? I just checked, is L here? Yeah, is L here? I did not check the actual frequency of, okay, in the very beginning, I had 2 L's. Here also I should have 2 L. If I have only 1 L, then actually only 1 L is present. And thus I should go ahead with only 1 L. So rather than the characters, okay, it's important to maintain the characters, but it is also equally important to maintain the frequency of the characters. So I will transform this entire thing, and again, not a big transformation, a small transformation, by saying B having a frequency of 1, E having a frequency of 1, L having a frequency of 2, A having a frequency of 1. Now this frequency will decrease. I know I have to take minimum at every step, because here I will again grab the frequency, and again these will be at max 26, because I know I have only 26 lowercase English alphabets or English letters. So I will now try to minimize this. I have maintained the frequency of all the characters. I'll just try to minimize this. Okay, is B here? Yeah, B is here. Okay, now, okay, B here. Firstly, grab what is the frequency of the characters in this word. L is twice, A is 1, B is 1, E is 1. Now make the new final one. How will you make it? Okay, B was 1 here, I have 1 here. Okay, minimize them. Aryan, why are you minimizing it? Why are you not taking this only? Bro, what if B would have been 2 here, but you only had 1 previously? So you can only take 1 B. In total, B can be only 1. Let's say I had 1 more B here, but still minimum, like as in the common one, B would be only 1 from here or here. So I will take minimum of the current B and the existing whatsoever I'm building up. So B will become 1. Then I will come to E. E is here, E is here also 1. Okay, E will also become 1. I'm taking minimum because I have to minimize it every step. L here is 2, L here is 2, again L becomes 2. A here is 1, A is not even here. A is here also. So okay, A becomes 1. So we realized that we got everything. Great. Now this is the so far combined result. Now let's go on to the next word. I go to this specific word. Again, check all the characters with their frequencies. Okay, R is twice, O is once, L is twice, E is 1. Now again make a combined result considering this result and the new words of high frequency. Okay, B here by default it says B frequency is 0. If it is not there, B frequency is 0. Minimize it. I will get a B frequency as 0. Okay, E frequency as 1. E frequency as 1. Okay, E frequency will be actually become 1 only. L frequency as 2. L frequency has 2. Okay, L will become 2. A frequency is 1. A is 0 itself. Okay, A will be a 0. Now, this is finally what I have got. So, this is saying that E with a 1 frequency and L with a 2 frequency was repeating in all of them. At least this is for sure there. And that is my answer. So, I'll just simply iterate on all the non-zero frequency elements and I get my answer. Cool. Let's quickly try run for the second case also. Now you realized how we reached on to computing frequency rather than going on to the actual elements. We grabbed the actual elements, but the requirement of frequency was when we realized that, okay, LL. I was checking L again, but now I realized I should know how many L's were there, and now currently in this word how many L's are there, and then only I can actually minimize my answer. That's where minimizing came in picture. Okay, let's complete this. In the very beginning, my A has frequency of n, B has frequency of n, C has frequency of n, because in the very beginning I'm assuming I have all the characters, 26 characters, and I know I can have at max n words. So for every character can have, let's say, n frequency. You can take anything. You can take maximum also, int max. Cool. Now what I did, okay, I went on to C. I said, bro, C frequency, I will say that, bro, C's frequency is what should I take? C's frequency I will take as 1. I cannot take it. It is 1. O frequency is 2. L frequency is 1. Okay, from this existing one which says all of them are there, I will get the answer as A will become, A is not there, so A will be for sure 0. A is 0, right? L, C, so it will become C as 1, O as 2, L as 1. Then I will go on to the next character. I'll go on to my next character and I again say, bro, L is 1, O is 1, C is 1, K is 1. So I will now take whatsoever earlier I have got. C as 1. Do I have C as 1? Yeah, I have C as 1. So okay, C as 1. O as 2. O as 1. Minimize. Now only I have O as 1. I have only O one time. That's it. L as 1. L as 1. Okay. L is 1. Okay. Now this is the new result which is formed. This is the new result. Okay. Let's see. C is 1. O is twice. K is 1. C I have 1. Okay. C is 1. O. Yeah, I have O. That's all too. Just once because I have only one O now so far. K. Okay. K. Sorry. L. Okay. I have no L. So L will be 0. So this non-zero frequency, C is occurring once, O is occurring just once. So this is my answer. In this case, E is occurring once, L occurring twice. So this is my answer. So that's how we can build the answer. Cool. Let's see the code. So firstly, I simply grabbed that elements, all the characters, and then I said, okay, word or size. Again, you can have it as int max also. It's totally up to you. Right. Now, it just saying for every character what is the frequency. Then I went on to all the words one by one. All the words one by one. For every word, I will grab its current frequency, which I was showing by making in the bottom. It's the word current frequency. So I will go on to all the characters of that specific word, grab their current frequency, and this is my current frequency of a word. Now, when this is done, I will have to find this thing. I'll have to find, if I just change the color, I have to find this thing, which is taking the previous frequency, minimizing it with the current frequency, thus making the new final frequency. Cool. So I will make a final frequency, right, of every character. Again, make sure to go on to every character, because in the very beginning you have put in, if you remember, in the very beginning you have put in maximum. So make sure if that A is not there, A's frequency is 0 in this portion, first character, so it should also be A equal to 0. Right. Now I will just minimize my final frequency with the current frequency which I have factored above. With this, I will get a new final frequency after consuming a specific word. I'll get the new final frequency, and this will happen at every step. It is just same as prefix sums. Take the prefix value, take the current value, find the new final frequency, right? Okay. Now, when this is done, the entire loop will generate the ultimate final frequency, which I should consume in the end. So I'll do the same thing. I'll iterate on all the characters of my final frequency. Again, in the final frequency, I'll just check. As you remember, in the very beginning, I showed you E frequency in the final was 1, L was 2. So E should occur once, L should occur twice. So while the final frequency is non-zero, that character should be pushed that many number of times. It is a way to, like in C++, you can just say I want a character of length 1. So this will convert to a string. A character of length 1 will be converted to a string, and thus I can get that specific character. Let's say C was having a frequency of 1, L was having a frequency of 2. It was E. So I'll just say E should occur once, and that's, I can just simply push it and just simply keep on pushing it. So it will, again, please don't do it a 2 because it can repeat the characters. So we just want a character as E. Okay, another character as L. Sorry, another string as L. Another string as L. We don't want LL. That's not what we want. Cool. Now, coming on back, we will get the answers. All these strings which have non-zero frequencies, and whatever frequency he has, that many number of times that character should repeat, and ultimately get the answer. So the time complexity for this, as we are going ultimately seeing, O of n into 26, O of n into 26 is the time. Space, as we are only using current frequency and final frequency, which is both of size 26, so it is O of 26 plus 26, which is again a constant time, right? Now, one quick thing, they have said that my words of I dot length is 100. My words dot length is 100. So imagining it is words dot length, which is n, it is 100. So if I'm saying if the n would have been 3, right, but the word of I dot length is not dependent upon n. So what if the word of I dot, like word of I dot length, which means the length of a specific word is actually, let's say, 100, right? So this is, again, the solution which you have seen will actually pass. But now I realized that there is some one flaw which the edge case, or basically the test case, did not find, which was that if my n is 3 and the each word size is, let's say, 100, so I will have 100. This is 100, like a word length. Okay, I have A, B, C, D, A, and so on and so forth. So it is 100 as a word size. So if it's 100 as a word size, so for sure, again, let's take it at 2 only. So I can say that every character can occur 50 times. If I have, let's say, 2 characters, A, B, B, it's A, B, 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 and so on and so forth. Again, let's say in the next time also I have A, B, B, and so on and so forth. So if I initialize with my word size, which is n, if I initialize with n is now 2. So he is saying in the very beginning, for all the characters, minimum frequency is 2 itself. But I can easily see the minimum frequency can be 50 also. Like it can be 50 also. So in this case, ideally it should have failed, but I don't know the test cases was there, but it should have been ideally int max according to me, and like int max, or maybe like this value, which is 100. You can say has 100. So this ideally should make sense, and not n, but for n it also passed. Cool. I hope you guys got it. Bye bye. Take care. Do join the Discord and do check the description. Sorry, comment section. Bye bye.